Welcome to the Sabtech Machine channel. In the previous episode, we discussed polyether selection for conventional foam. Today, we move into a more advanced topic, the formulation logic of high-resilience foam, HR foam. Producing high-quality HR foam starts with the right high-resilience polyether, HR PPG. In industrial production, selection is mainly based on molecular weight. The first option is 5000 molecular weight polyether. It provides higher hardness and is commonly used on continuous foaming lines. The second option is 6000 molecular weight polyether. It offers better resilience and a softer hand feel, making it the preferred choice for premium HR foam products. Why is HR foam formulation more difficult to adjust than conventional foam? The core reason lies in the high reactivity of HR polyether. This high reactivity defines four critical formulation points. 1. TDI index. HR polyether reacts extremely fast and tends to consume TDI aggressively. Therefore, the TDI index must be increased. If it is too low, the foam will lose resilience and suffer from severe closed cell issues. 2. Silicone surfactant selection. Highly reactive polyether must be matched with a low reactivity, HR-specific silicone oil. If a high-activity silicone designed for conventional foam is used, excessive closed cells will occur. Conversely, using HR silicone oil in conventional foam formulations will lead to foam collapse. 3. Crosslinker. This is the biggest difference between HR foam and conventional foam. HR formulations must include a crosslinker to build a strong polymer network, ensuring toughness and structural stability. 4. Catalyst fine-tuning. Since the polyether itself is highly reactive, the dosage of tin catalyst, T9, should be reduced appropriately to prevent overly violent chemical reactions. Finally, many manufacturers try to improve resilience by adding HR polyether into conventional foam formulations. This is technically feasible, but with two important limitations. First, do not add it to low-density formulations, as the reaction becomes too fast and can easily cause scorching. Second, do not add it to high-water formulations, which can destabilize the system and significantly increase the defect rate. With this, our series on flexible PU foam polyether systems comes to an end. From raw material characteristics to formulation logic, we hope this content supports your production work. If you need high-performance polyurethane foaming equipment, or one-stop technical support for raw materials and formulations, feel free to contact us. Thanks for watching. Please like and subscribe for more professional insights. See you next time.